Hello everyone, welcome to the past paper discussion. In this video, we're going to discuss the last question of the series. Let's get started. It is a trigonometry like sinusoidal application based question, right? And it's also quite an interesting one. So pay attention till the last. Okay, here, the time of sunrise or hours after midnight in Taipei can be modeled by the first equation. Sunrise is defined by the model. It's modeled by R. 1.08 times cos 0.0165t plus 0.413 plus 4.94. And then what is the t here? T is the day of the 1 year, day of the year 2021. For example, if I mean t is 2, it represents 2nd January 2021. Next model is, again, it's a cosine model. It is defined by S, hours after midnight in Taipei, which is S is equal to 1.15 cos 0.0165t minus 2.97 plus 18.9. And they have provided one more model which define the number of daylight hours in Taipei during 2021 is modeled by this. Okay, now these are the informations given, like 3 model is given to us. We need to find the value of A, B, and C that we can spot in the function D, right? And one more, this carries actually 6 marks, a high weightage one in this particular. And B part is hence or otherwise find the largest number of daylight hours in Taipei during 2021 and the day of the year on which this occurs, right? And we can just start it. First, daylight hours, they have given a model. We can frame one more model, right? Because sunrise and sunset. So sunrise. And I have the sunset. So daylight hours, how we will calculate sunset minus sunrise. So D can also be framed in this way. D is equal to sunrise minus sunset. Sunset minus sunrise. So S minus R. Right? So that's the first approach. Let's go. So it's basically just copy down. Only this intercept value can be subtracted, right? So this will go like this. D is equal to S is 1.15 cos times cos 0.0165t minus 2.97 plus 18.90 minus 1.08 cos 0.0165t plus 0.413 minus 4.94. Okay, so D model is also there, but we can find in this way also. Okay, I'll just copy this. What is the only thing I can reduce here is 18.90 minus 4.94. I can just do that one. Let's do and simplify it. The simplified version can be this. So this will become 18.90 minus 4.94. It's going to be 13.96. So plus 13.96. Now let me compare the given D, which have a lot of unknowns, like 3 unknowns. Cos 0.0165t plus B plus C. Right? So when I compare this and this, okay, this is quite problematic. But the intercept value, like it's very like the midline, right? So that is quite easy. 13.96. So I got C first. That's the simple way. So C is 13.96. And don't always focus on finding A first. So it can be in any order. Okay, first C is done. And next I need to only find A and B. Right? So next easy thing is, which is outside is always easy, right? A is easy one. Right? A is nothing but amplitude of this graph. Okay, what is amplitude formula? Amplitude is maximum minus minimum over 2. A is nothing but amplitude here, correct? So how to find maximum and minimum of this D? Actually, this is the only hope we have here, not this. This is just blue color D function is just for comparing, right? We are working on the blue D. We are using the red one. And I'm going to graph this actual D where I know everything. And I'm going to graph it. There I can find maximum and minimum, right? So now it's time to switch to the graphical part. Okay, go for a graph and give that big function without any mistakes. Cos 0.0165. There we are just using t, you just change it as x here, minus 2.97, then out, minus 1.08 if I'm not wrong, cos 0.0165x plus 0.413. See, I did a mistake. The plus is outside and plus 13.96. That's it. I have hit the enter, but no graph is over here. So let's go for window settings and go for zoom fit. It will fit the data. Now I can see at least a part of a graph. Now I need to zoom out to see the entire structure of the graph. So just I get into zoom in and I'm just clicking on the center. Now we can just adjust it over here. Okay, I'm working like on the first quadrant. So it's a kind of nice sinusoidal function, right? And here I'm going to analyze what is my aim actually, finding maximum and minimum. And you can take any interval and find maximum and minimum. Okay, so 16.1738. That is my maximum. Can you see that peak point? And then minimum, like you can go for analyze graph, minimum in the same way. So just choose your lower bound and upper bound near this minimum. I got my minimum. So we are not taking X value here. The time is not we are working. We are working at the maximum and minimum. So I got these two. Amplitude also we can just find it over here. So it is nothing but maximum minus minimum by 2. So by 2, maximum I spotted like 16 point, that one, minus, let me copy that one too. Minimum value 2.2138. Great. What is this? This is my A. And now let's get into the solution page. Let's update this A in that model. Okay, I got A as, from the graph we did everything. So we got 2.2138. You better take this. You can just round off the final answer. Okay, now since we have to find D, let it be in this form so that we will get accurate value. Okay, don't round it off here. That's the definition. But yes, still if you round it off, the answer is accepted. That is not a problem. And moving over. Yeah, now the blue D is getting updated little. I know C value and I know A value. Only one more thing we need to work on. Okay, so here let's update the values. Instead C, it's 13.96. Instead A, it's 2.2138. You can even take 2.21. That is also fine, no problem. Okay, only thing I need to find B. Okay, I know this is 1D. I have another D equation also. Let me take that. Okay, so let's take this one. Wait a minute. We want this D again to find out the B. Right. So what should I do? B is inside. So amplitude and y-intercept, that was quite easy. But what can we do here? Okay, when time t is 0, what is D? I can find it from this D. Then I will do the same thing. Why I pick time 0 means you can do anything, but time 0 is better to calculate. So use this strategy. When time t is 0, what is D? So I will get 1.15 cos. This will vanish when time is 0, right? Minus 2.97 minus 1.08 cos. This will vanish 0.413. Oops, something is missing, 13.96 in this D. So plus 13.96. I will calculate this value again, switching to the calculator. Let's quickly do this. It's just a normal calculator page, right? So I'm solving for 1.15 times cos negative 2.97. Then minus 1.08 times cos 0.413. Then out plus 13.96. Okay, make sure every decimals and zeros stuff are placed correctly and click enter. I got this 11.837, 8377. I'm going to use it over here, right? So this is the value when time is 0, when t is 0. This is all we got, 11.8377, right? So let me approximate and use that same value I got in the calculator. So when t is 0, t is this, 11.8377. Let it be. And moving to the blue D, right? Where it is missing. So substitute that. So this one you substitute in. Let me make it as a prime equation like star or something. In star. So D is 11.8377. I replaced it. Then I have 2.2138 times cos t is 0, right? So what will happen when t is 0 means this full thing will get 0 and b is an unknown I'm looking for. So I will get cos b and plus 13.96. That's it. Now this has only one unknown, which is b, and we need to solve for it, right? Now we can just get into the calculator page again to solve this. I have an equation now, right? So what I'm going to do is go for algebra and numerical solve and type in your equation 11.8377 equals 2.2138 times cos of b I have plus 13.96. I'm solving, comma, what you're solving for. We are solving for me. And that's it. We got 2.85308. Good. So now taking this, and this is nothing but my b value, correct? So that's it. We got b also. So last unknown is also found. We got b is equal to 2.85308. It's an angle, correct? B is an angle. And I have to include one more thing here, which is negative. Why? Because the question, it's like going back to the question, you can get it. So actually what the question is made of, so sunrise and sunset after midnight, right? So it is actually, they are trying to mean a clockwise direction. In clockwise, we will get a negative angle. So that's why we interpret in that way. Calculated give us a positive one. But we know the model, right? So B is negative 2.85, right? And so finally, listing out all A, B, and C. A is 2.21, approximate to 3. And B is this we have. C is 13.96. That's the actually first thing we did. 13.9 minutes will be 4. But anyways, these are the values we got here. Right. And first part is done. That's so simple. Moving to the next and the last. So in this case, hence or otherwise, you can use the things you have find it so far, or otherwise you can solve for this question. What's that? So the question says, find the largest number of daylight hours in Taipei during 2021 and the day of the year on which this occurs. Right. Let's get started. Okay, now I know the daylight hours completely. So let me take that. 2.21 38 cos 0.0165t minus 2.85, right? We got the B like that. Minus 2.85 plus 13.96. Okay, how to find largest? They're asking maximum. That's it. So find the maximum of this function and the day on of the year on which this occurs. Yeah, both we can get it from calculator. Moving to the calculator page. So go to the graph. Okay, let me take a new graph. Okay, here. 2.2138 times cos 0.0165x negative 2.85 plus 13.96. This is the daylight hours, the maximum daylight hours we are. I clicked enter, but the graph didn't show up. So first go to Windows settings, like zoom fit. I got a part of the graph. Now you need to zoom out to see the full structure of the graph. Yeah, it's kind of similar to the previous one. Okay, and we are looking for the greatest number of daylight hours and in which day it occurs, right? Let's move. Go for analyze and maximum. This one is a maximum I can see. It's 16.17. Okay, I can approximate it like 16 point. This is also maximum, right? So maximum occurs at a lot of the places. So let me take 16.17 as maximum. But on which day of the year 2021? So this is 553 third day. It is not at all in that 2021, right? So this is not the best thing. So go for the previous peak, analyze maximum. This one can be, I got this. So it is the X values and within the year limit, right? So that 172nd day or 173rd day and 16.2 is the greatest daylight hours. This how we need to interpret. This is not. Okay, so let's copy this and interpret the result. Over to the solution page. That's simple. So how can we see? They are asking the largest number of day hours and the day on which it occurs. So for 16.2 is the largest and hours is the largest daylight hours and it occurs at 172nd.2. So you can just go with 173. This completes the solution. And that's it. We have completed this series. We will meet in the next series very soon. Thank you so much for listening and learning with us. Keep in touch. Keep learning.